Good evening, and on behalf of the Islesboro Forum Committee, welcome to the first program of the 2021 Islesboro Forum Speaker Series. I am Gail Jackson and the moderator of today's program. This is our 29th year of presenting distinguished speakers who are experts in many different fields, and we present them to the island community. Last year, because of COVID, for the first time, we presented our programs live via Zoom webinar rather than in person. Many of you have been asking, how will we do it this year? This year, we have 7 programs scheduled, one more than last year. The first 3 will be via Zoom. For the final 4, we will have the speakers in person at the community center, and as well, the program can be watched via Zoom, so a hybrid form. We hope to welcome as many of you as possible in person for the final 4 programs. The entire calendar of programs is listed at the website, islesboroforum.org. Before I close these introductory remarks, I want to acknowledge and thank the 7 other committee members for their terrific support and ideas. Their names are listed on the website. Also, thank Michael Hutcherson for his expert work as our technical producer. Finally, please share your comments and speaker ideas for future seasons via our website. And while you are there, please consider making a donation. Our costs for 7 programs will be about $1,500, not counting the many happily donated volunteer hours that the committee provides. We hope you will want to support the speaker series with a donation of as little as $10 or more if you're so inclined. A quick reminder as to our format. Once our panelists have completed their remarks or our speaker, we will have time for question and answer. You should find the Q&A function on the bottom right of the Zoom webinar screen. Type in your question, hit the enter button, and the moderator will recognize you according to where you are in the queue. Now, I'd like to turn the program over to Forum Committee member Peter Rothschild to introduce our speaker. Peter has been an invaluable committee member over the years and is, in addition, the son of the late Robert Rothschild, one of the original founders of the Forum. Peter also served for many years as Chief Investment Officer of the Maine Community Foundation. Peter, over to you.
Thank you very much, Gail, and welcome to Dr. Abe Miller-Rushing, Science Coordinator for Acadia National Park. I'm sure everybody here is pretty familiar with Acadia National Park, but it is interesting that it has had, I think, somewhere around 4 million visitors a year. It is almost 50,000 acres, and it includes 40 miles of shoreline. I don't know if there are other national parks that have non-contiguous pieces, but as you may know, a large bit of Ilaho and also the Schoodic Peninsula are part of Acadia National Park. Dr. Miller-Rushing has been a wildly creative and imaginative coordinator of science, and I'm sure that we all are concerned and very interested in the impacts of climate change, global warming, sea level acidification, the impact on all different parts of the environment on Maine's premier natural area. Amongst the other things that Dr. Miller-Rushing has been involved with is the Second Century Stewardship Initiative. And they have 12 fellowships that date back to 2017 And I am fascinated to learn recently that a great deal of their fellowships are actually studying the impact in very multidimensional ways on Maine's environment of climate change. So with that, I would love to turn this over to Abe and have learn a lot about how Maine's waterfront, its natural areas are being impacted by climate change, and hopefully what we can do about it. So over to you, Abe.
Yeah, well, thank you very much, Peter, for that very nice introduction. I really appreciate it. And yes, I kind of have to pinch myself when that they pay me to work here. It's a dream job. I'm gonna just start sharing my screen here. Get my talk up and running. There we go. So I'm going to be talking today about managing for climate change in our national parks. And I'm going to be talking primarily about, I'm going to be using Acadia as an example for stuff that's happening all across the National Park Service. I'll come back to the kind of bigger picture right at the end, but do know that almost all of the issues I'm going to be talking about here are happening all across the country. And I also want to acknowledge that the work I'm going to be talking about is represents the work of a lot of people, not just me. I get the benefit of getting the chance to talk about it and work with all of these folks. So just to give you an outline, I'm going to go through kind of a timeline of Acadia and how our management has been impacted by climate change and how we're really having to at a very fundamental level change our approach to managing national parks because of climate change. So some of the ways we initially planned on, the National Park Service planned on managing things, we just aren't possible anymore. And so I'll walk through that here at Acadia. And before I get into this, I'm gonna be starting my story in the 1880s, just before the foundation of Acadia National Park. But I want to recognize that the ecological work in this area and people in this area goes back much farther. The Wabanaki tribes have been living on and studying the ecology of this area, and it's continuing now. This photo is from work going on with harvesting of sweetgrass used in basket making in Acadia. And there are other Wabanaki research projects going on in the park today. And so the tribes continue to have a connection with the land, and Acadia is on Wabanaki territory. So I'm going to start my story with Charles Eliot and the Champlain Society in 1880. So Charles Eliot is one of the folks in the image to the left there. He, in 1880, asked his dad if he could borrow his family boat and bring 12 of his buds up to Mount Desert Island to spend the summer. And his family had been coming up here as he grew up. And his dad said, yeah, sure, you can borrow the boat, but as long as you do something useful when you go up. And so they had a kind of an interesting idea of how to do something useful. These guys were all Harvard students, and they decided to do science when they came up. So they developed each of them kind of took on a different department. So there was an ornithological department, a botanical department, a ichthyological department, and geology. And that's a picture of their camp on the right-hand side. And they ended up writing reports like this on the left. That's a picture of their flag. They had a camp flag at their camp that they raised every morning and sang a song. But one of the things they were doing as they did their science was also noticing how remarkable the biodiversity and scenery of this area are, and that it really needed to be protected and deserved to be protected. And so it turns out that they ended up coming back over a number of years, and they did a lot of really important science. So they did the first Western science on Mount Desert Island, and this was citizen science. They weren't doing it for money. They were doing it in their free time, weren't getting college credit for it. And they worked with some of the locals, like Edward Rand, who was one of the Champlain Society students, worked with John Redfield here to document, who is a local lawyer and accountant. And they, together with some other folks, documented the complete flora of Mount Desert Island, which I'll come back to later. But they kept returning and kept doing really important science. Charles Eliot ended up going on to work with Frederick Law Olmsted. He became a landscape architect and worked with Frederick Law Olmsted in Boston, and actually helped develop the first land trust in the country, the trustees of reservations. He was really important with that. But he ended up dying early at age 37 of spinal meningitis. And his dad at that time was understandably very upset, very distraught, went back to the Champlain Society journals that documented Mount Desert Island and his son's dream of protecting that area. And his father was Charles W. Eliot, and he was the president of Harvard University at the time. He was in a good position to do something about this. So he worked with John D. Rockefeller and George Dorr and created the second land trust ever, the Trustees of Reservations for Hancock County, and ended up buying up or getting donations of land that they then donated to the federal government and to create Acadia National Park. And so Acadia was inspired by the citizen science that was done in the 1880s, the work of the Champlain Society. And Acadia is actually one of the only national parks that has science written right into its founding legislation for why it exists. Into one of its reasons for protection was to study the plants and animals and geology of the area and history of the area as well. And so early on in the history of the National Park Service, which was founded the same year as Acadia in 1916, the management goal at the time was to preserve things as they had been historically. So as they had been at some previous time, like in general, it was pre-European contact was a management goal. And so people like Starker Leopold said that termed this kind of the national parks for preserving vignettes of primitive America. And so just keep that in mind as we move forward here. So kind of a bottom lines of this kind of first section of the talk is that science and citizen science were instrumental to Acadia's creation. And the initial management goals were really to maintain historical conditions, to keep things as they were in the past. And that was really typical of all conservation, like conservation, restoration, preservation, all backwards looking, kind of keeping things as they were, keeping things from changing. So my next story, and you'll see that in each of these kind of sections, I'm going to focus on individual people as kind of an element of how to tell these chapters of the story. The next person I'm going to kind of focus on is Glenn Mittelhauser, who is another college student in 1988. He was more local, so he was at the College of the Atlantic in Bar Harbor, and he had a passion for natural history, and really took on that passion and he worked with his advisor, Craig Green, to repeat some of the work of the Champlain Society. And in particular, he was really interested in documenting the flora of Acadia and revisiting that flora that Rand and Redfield had done back in the 1880s. But it turns out that the funding for documenting floras for kind of passion projects like that is tough. Glenn is very talented, and so he got pulled in other directions too. We actually hired him. He's in the back row, second from the left there, in a Park Service uniform. So we hired him for a summer to work with some of our first citizen science group of Earthwatch volunteers in 1990 to document the biodiversity of our offshore islands, actually, several of the offshore islands for Acadia. And so he subsequently went on to get his master's degree, started his own business, doing natural history work. Actually, the Maine Natural History Observatory is his business. But meanwhile, he kept doing this. He kept on with this passion project of his. He had a family, kept on this passion project, and then just about in 2005, they finished and published this flora of Acadia National Park. So they finished updating the flora, they published the scientific paper version of it, and this beautiful field guide that some of you may be familiar with. If you don't know it, I encourage you to get it. And so they updated it. And so, but what was really surprising to us was what they found. And one element of what they found is that 1 out of every 6 of the plant species that the Champlain Society had documented were gone. So these 1 out of every 6 of the plants that were here in the 1880s no longer occur in Acadia. And these were disproportionately particular species, particular families like the lilies, the orchids, or the mints are some of the families that were disproportionately impacted. And it turns out that around the same time, we were noticing a lot of other major changes going on in our environment. We were noticing large declines in our seabird populations, in large part because of mismatches with their fish food that they feed on. In the bottom left there, you see a bioblitz taking place in Acadia, and those we had more than 10 years of bioblitzes focused on documenting insects, and they documented over 500 new insect species to the park. And so we knew that our insect communities were changing dramatically. The top right is an image of looking at mercury pollution and other kinds of pollution, taking a core, a lake sediment core, looking while it was frozen, and so documenting mercury pollution in Acadia. And then the bottom right is studying acid rain and its impacts on our lakes. So there are lots of changes taking place. And climate change is a major driver of these changes. Not the only driver, but certainly a major driver. And so temperatures in coastal Maine have warmed by about 3 degrees or so over the past 100 years. This is temperature on the y-axis on the left here, and then across the horizontal axis is year. And a key thing to notice here is that not every year is sequentially warmer. So you can kind of follow the ups and downs, but we still have years as cool as they were in the 1950s and 60s. And so it can be hard to just notice, although it's getting easier to notice because we are having years warmer than ever on our record. And just to put that in a little bit of context here, the warming expected in Acadia by the 2080s, so just 40 years or so from now, or not, just 60 years or so from now, is about 4.5 to 10 degrees Fahrenheit. And the temperature since the last glacial maximum, about 20,000 years ago, when there was about a mile of ice on top of Acadia, it's about 8 degrees Fahrenheit. So even though the temperature doesn't sound like a lot, there can be bigger temperature swings from one day to the next. Ecologically, it's the difference between having a mile of ice on top of where we are and it looking like it does today. We're also getting wetter. So this graph, it has precipitation on the vertical axis here and year on the horizontal, and we're getting about, on average, about 6 inches more rain and snow, so combined precipitation each year. But you can see again, there's a lot of variation. You can see that one of our driest years happened around 2000. And so there's just a lot of variation, and more of this rain is happening, more of this precipitation is coming in big storms and falling more as rain than as snow. And so kind of put this into context, extreme rainfall events that used to occur every 50 years now occur every 12 years. And so we end up having to plow or sweep a lot of our coastal roads or deal with floods of areas. That bottom picture is near Sourdemont, is at Sourdemont area of Acadia, if you know the park. And so even just a month ago, we had a rainfall where we got 4 to 6 inches of rain in just 3 hours, and led to a washout like this in the Scudic section, Scudic Peninsula section of the, just outside the Scudic Peninsula section of the park. We did experience washouts inside the park as well. But it was just a lot of rain that infrastructure can't handle. We have over 1,000 culverts in Acadia, and they're almost all undersized because they were built for past conditions. The ocean is acidifying currently more rapidly than it has at any time in the last 300 million years. And this is tough for anything that has a shell or a bone exposed to the water, because it becomes harder to grab calcium out of the water the more acidic the ocean water is. And so we think that the ocean acidification maybe is likely contributing to recent declines, for instance, in our mussel populations in the park and along the whole coast of Maine. And just a couple more examples here. That one is the climate change is helping non-native invasive species like purple loosestrife. So that's a monarch butterfly, totally native. We love monarchs, but the plant is a purple loosestrife. And at the bottom is a black-legged tick, which carries Lyme disease and some other diseases. You know, these things couldn't survive our winters and didn't in the past, and now they're here. They're able to take advantage of our longer growing season. Our growing season from last frost in the spring to first frost in the fall is about 2 months longer than it was 100 years ago. And these non-native species are able to take better advantage of that than our native species. And the last example I'll use here before coming back to the kind of stories is to say that phenological shakeups and mismatches are happening. So phenology is when things happen in nature. So when plants flower, when birds migrate, when frogs call. And it turns out that that's one of the most sensitive biological responses to climate change. So by and large, plants are flowering and fruiting earlier. There's a lot of variation. Some are fruiting a little bit earlier, some are fruiting a lot earlier, some aren't fruiting earlier, but by and large, on average, plants are fruiting earlier. This is tough for fall migrating songbirds, which are migrating later each year, and there's a lot of variation among the birds as well. But by and large, on average, they're migrating later. They're taking advantage of longer seasons on their Arctic and boreal feeding grounds where there's food available for longer. And some of them are coming through so late that we can't, on our transects where we're monitoring fruit and these bird interactions, we can't find on our sampling transects, we can't find any fruits. But the birds are able to find the fruits, it turns out. We're sampling them as well. And in their feces, they're still finding the fruits. But we're concerned that as this mismatch gets bigger, there may become bigger problems for some the latest fall migrating birds. And then these fall migrating raptors are migrating at the same time each year. And some of these guys are feeding on the songbirds. And the idea here is just that you can imagine with all these changes in timing, the interactions are really changing and getting disrupted. And so there are going to be some winners, some things that were getting eaten before that aren't getting eaten now. And but there also be some losers in this scenario. So these changes are dramatic, even though they're not visible. So almost all of these examples that I said, most people don't notice because the postcards of people when they come to Acadia really look pretty similar. You still see our spruce fir forests along the kind of dramatic rocky coasts. You still see plants, you still see birds, but we know that the ecosystems are really very different now. And so we have to respond, but how do we do that? So I'm going to come into the third chapter here of this, and here I'm going to focus on Judy Connery, who arrived at Acadia in 1986, about the same time that Glenn was doing his thing. Glenn Middlehauser was doing his thing at College of the Atlantic, documenting the flora. At this time in 1986, so Judy came, she was a graduate student, so she was fresh out of grad school at Cornell and came here. And right before she got here, another grad student had identified that we might have an invasive plant. So invasive species were just becoming recognized as a big problem in ecology. And these are species that do so well, they displace native species. And so this grad student identified that purple loosestrife that I mentioned before, and said, there's this big population of purple loosestrife in one wetland, and I think it's causing problems, so we should get rid of it. And I think 1 year of management ought to do the trick. And so Judy, when she got here, she was put on this. She was put on to go out and get rid of the purple loosestrife. And it turns out the purple loosestrife is harder to get rid of than they had thought. That each one of these, this is a picture of these purple flowers, are all purple loosestrife in a meadow. And each one of these plants can produce more than 1 million seeds a year. And so getting rid of if you were able to get rid of all of the living standing plants, they're going to grow back from seed. And so it ended up being a bigger challenge than they thought. And Judy was like, okay, I'm up for this, and I'm going to totally take this on. And we took more drastic actions than the Park Service historically had liked to. We generally try to take hands off. But here, the problem with these invasive plants was so severe that we used herbicides to help control some of the invasive plants. We were very particular about how we use it. We still use herbicides on these invasive plants, but the idea is that on the left, there's a picture of a drip applicator. So instead of spraying, it's just dripping on individual plants. And that kind of barrier in the back, the white kind of sign looking thing, is just keeping the herbicide from rubbing onto the native plants there right behind. And then the right-hand photo is applying herbicide using a glove to individual plants. And here the judgment call was made that the invasive plants are more harmful to our native ecosystems than the herbicide is. And we've collected data to kind of ensure that that's the case. And so it turns out Judy was able to do awesome, and her crew was able to really knock back the purple loosestrife. But the more they looked, the more they realized that there were other invasive plants that were here. And these are things like garlic mustard, Oriental bittersweet, Japanese barberry, and glossy buckthorn. And almost all of these plants are here largely because of climate change. They're able to shift their seasons, and they're able to take advantage of our longer growing season better than our native plants are. And so at the same time, Judy was discovering that invasive plants are maybe becoming an overwhelming challenge. We were also tackling other problems. And so we were dealing with things like peregrine falcon restoration after DDT. So we were trying to restore peregrine falcons to the park after their populations had been decimated by DDT. We were dealing with acid rain and also mercury in our fish. We had some of the highest concentrations of mercury in our fish of anywhere in the state of Maine in Acadia. And so these were big challenges that we needed to face. And so the conversation became, how should we give up on managing the invasive plants, given that it's maybe an overwhelming challenge, and given that we really need to focus on some of these other challenges too? But Judy, it turns out, was collecting data, which was at the time not such a usual thing for resource managers. This is from one of her sets of transects where she was managing purple loosestrife, showing that the number of stems and over time how effective their management was at really controlling the invasive plants. And so instead of giving up on invasive plants, managing invasive plants, she actually managed to convince, because she is stubborn and she is persistent and very an amazing woman. She's recently retired, but she had an incredible run of it here at Acadia. She convinced the park leadership to really step up the effort and even invest more in managing invasive plants. And so over the 30 years since Judy started our invasive plant management program, it's probably the most successful program in the Eastern US. And at this point, we really are mostly managing new invasions or re-invasions of plants. So it's really been an incredible success story. But right as we were patting ourselves on the back, and deservedly so, patting ourselves on the back, we realized that, and we thought we were trying to really prevent this change in invasive plants, doing like preserve these kind of vignettes of primitive America like we were trying. But we realized that, we couldn't really hold back the changes that were happening. And so here in this picture, it's maybe hard to see, but if you squint, you can see that there are big patches of dead trees here in the area circled on in red. This is Norumbega Mountain, and these are red pine trees. And about 6 years ago, we identified red pine scale in Acadia, an insect native to Japan. And over the following 3 years after we identified this invasive insect pest, it managed to kill all of the red pine in Acadia. And so in just 3 years, we lost an entire species from the park, which kind of goes to show that even though we were really strikingly successful at preventing one type of change, we weren't able to hold back other types of change that were happening. And so we really recognize that we can't preserve these vignettes of primitive America. And again, this is true in Acadia, but it's also true in other national parks and protected areas across the world. And so we have to manage change and preserve the ecological and historical integrity and resilience, and try to keep our parks healthy. And so how do we do that? And this is a big challenge. The last two people, for this last chapter, is our current superintendent on the left, Kevin Schneider, and our head of resource management, Rebecca Colwill. And those two and our whole team here at Acadia right now are really charged with continuing, like, reinterpreting our mission. And our mission in the National Park Service is to preserve unimpaired, preserve our natural and cultural resources unimpaired for this and future generations. And so we're still in the forever business, keeping these things healthy forever. But now we have to think, what does that mean? How do we keep a place healthy as it changes? And so that'll be really the subject of this last chapter. And so we're having to really rethink our management policies. So all of these policies that were written to really help us prevent change, we have to think about how do we manage that change? And the way we're thinking about that is along this kind of using this framework of resisting, accepting, or directing. And we're thinking about when should we be making these decisions to resist? When should we be making these decisions? When's it most appropriate to direct? Or when's it most appropriate to accept changes that are happening? And when is it appropriate to actually get more hands-on and direct changes that are happening? And so to go through this, how we're thinking about this in Acadia, our forests are healthy. They're mostly red spruce. And this is currently continuing to regenerate. They're beautiful forests. We have actually among the healthiest forests in Acadia measured of anywhere in the Eastern US. But here's a list of our 10 most common tree species in Acadia. So you can see that red spruce up there at the top accounts for about 40%, or about 2 out of every 5 trees in the park is a red spruce. You can see the red maple and other species are in our top 10. And when Nick Fisichella, who's the current CEO at Schrödinger Institute, he worked for the Park Service before he went over there. And when he did some modeling, looking at how we should expect, he and colleagues at the Forest Service and in academia did some modeling and looked at anticipated change in these trees based on climate, based on future climate change expected by the year 2100, so in the next 80 years. And 9 out of the 10 most common tree species in Acadia are expected to decline or disappear entirely from Acadia over the next 80 years. And that includes our red spruce, includes well, every species on this list except for northern red oak, which is expected to just persist at current levels. And so you can see that this really means that we are expecting big changes in our forests here. So moving from this kind of boreal forest, which we have right now, to something more typical of southern Maine or Massachusetts or the mid-Atlantic, kind of more oak, hickory, birch, mixed hardwood. And so what happens if we accept change and are kind of hands off? And this brings us back to kind of our invasives issue. And so if we're not actively managing, and we can look to national parks to our south for what might happen, we would expect well, anyhow, what might happen. And so these pictures are from, this is gonna be a series of pictures from Morristown National Historic Site in northern New Jersey. But this is happening across southern New England in forest right now. And so this is in 2009. And the shrub layer here is Japanese barberry by and large, an invasive plant. And then 4 years later in 2013, you could see the shrubs encroaching. And then 4 years after that in 2017, the shrub layer has really just choking out the forest. And what this ends up doing is this density of invasive plants is choking out the ability of these trees to regenerate. So these forests aren't regenerating. And so we know if we're hands off here that invasive plants are likely to spread. We also know that these invasive plants are in fact choking out forests south of us. And so what we would normally expect is these forests south of us to move to the north. But we know that climate is changing faster than the trees can keep up with. We know that we've put a lot of obstacles in the way of these trees. And so they're not able to, there are obstacles like cities and development and roads and farmland and whatnot that prevent them from moving. And we also know that deer, herbivory, and other factors are also slowing the movement of these trees. So we're pretty sure that the invasive plants will be able to get here just fine, but that the native trees won't be able to get here. So accepting this kind of change is not really acceptable. At least that's what we think. And so what we're also thinking about resisting to buy time in certain areas. So where should we be resisting change? And so we plan to continue to remove invasive plants. We will probably be doing this at some level for forever. But we're really viewing it right now as being very aggressive to buy ourselves time to set our forests up to change, to have native species kind of facilitate the change in our forests rather than these invasive plants. We're also identifying what are called climate change refugia. So these are areas in the park that are likely to warm slower than other areas and will likely provide refugia for species of plants and animals that are sensitive to warming. And so in Acadia here, clear from the yellow to the purple, these are all kind of areas of the park that are likely to provide refugia. This particular map shows for a couple of plant species, I think black crowberry, maybe 3-2 cinquefoil. The kind of darker gray is ocean. The lighter gray is land that won't provide refugia. And then the yellow and purple is land that will provide climate change refugia for these plant species. And the areas that are likely to provide these refugia are on our summits and along our coastal areas, and particularly our offshore islands are likely to provide key refugia for plant species that'll warm more slowly than other areas. And so what we're trying to do is really try to limit impacts to these areas and really limit the impacts well, try to manage them to be able to provide refugia and limit change. And where might we and when might we be thinking about directing change, kind of getting our hands on and actually pushing changes in particular directions? And this is probably the very newest area of thinking in all of conservation, and we're still wrapping our heads around how we ought to be thinking about this. one of the ways that is common, people are commonly talking about directing change is by actively moving plants or animals from one place to another. So I mentioned that the native trees to the south of us are going to have a hard time getting here on their own. So one option is we could actually help them get here by planting them, by moving them from like Massachusetts or New Jersey or even or other locations up to Acadia. And so we were part of a group, the National Park Service agency-wide, and a bunch of academics have worked together to kind of develop a way of thinking about the risk associated with this managed relocation, this movement of plants and animals. And so we've developed an initial kind of assessment tool to think about the risks, both the risks to the species that we're moving and the risks to the ecosystems we're moving them from and the ecosystems we're moving them to. We're also testing the growth and survival of new plants that we might think about moving. So this is work being done by the Skudik Institute and colleagues at the University of Maine and being led by Nick Fisichella, where they have these raised beds, raised kind of garden beds where they're planting tree species from areas to the south, from Massachusetts and Maryland and Virginia, and planting them alongside some of our native trees to see how they perform. One, will they survive? Can they survive our cold winters? Can they survive our climate conditions? And which ones seem to do too well and maybe might look like they're invasive here, might be invasive, like a black locust kind of tree might do too well when it comes here. And so that kind of experiment, they have that located all at college campuses across the state of Maine and in Acadia, and looking at, and this is helping us identify species that might be good candidates for moving across places. We're also exploring the role of seed predators. So it turns out that small mammals like squirrels and chipmunks and voles and things that eat seeds, they play a big role in which trees do well. They can eat and destroy the seeds, or they can cache them and essentially plant them and help disperse them. And it turns out they really like helping to disperse big hard seeds like acorns and hickory nuts. And so this is work done by Alessio Mortalliti at the University of Maine, helping us really understand how our small mammal populations might interact with new trees as they arrive. So he was doing these food choice experiments with trees, with our native trees, as well as trees from southern locations. And then this is work being done by Chris Nadeau at Northeastern University. He's developing model ecosystems to test methods. So these are rock pools. So on the left there is a rock pool. This is a freshwater, essentially like a puddle at the upper end of our intertidal areas, or above our intertidal areas on our rocky coast. So these are freshwater, and they're whole little ecosystems. They have Daphnia, kind of water fleas, mosquitoes and beetles and algae and all kinds of things in there. And it turns out you can replicate them in these kind of Rubbermaid tubs or in the lab, like he has on the right, and use them like the lab mice of whole ecosystems. And here you can use them to test the effects of climate change on them. You could test managed relocation and have an idea of how management actions might play out on whole ecosystems in these kind of tubs before we start doing it in nature. We're also working with our community partners. Right now, this is perhaps most evident with our work that we're doing with our kind of clamming and worming and other folks with ties to the intertidal with Department of Marine Resources, our researchers, students, and others, because it turns out that managing for climate change, like there's a lot of values that go into how do we make these decisions. It was one thing, people in the field of conservation kind of took it for granted when we were working to keep things as they were in the past. But now, where we're trying to manage for change, there really need to be a lot of conversations around, well, what do we want? What are the desired conditions? What are the things we value as things change and we want to keep from changing or have changed more slowly, and where are the things that we want to be more active on? So this involves a lot of conversations with folks involved. And we're also been lucky to get resources from foundations, as well from private foundations, as well as from the National Park Service and other federal agencies to take on 3 big kind of pilot restorations where we're testing out these ideas of how to balance and mix these kind of resist, accept, and direct techniques. One is on the left, Bass Harbor Marsh, the biggest salt marsh in the park. Another is in Great Meadow, the biggest or second biggest freshwater wetland in the park near the Sieur de Mont area. And then third is on 3 summits, which have subalpine, very unusual subalpine vegetation. And these are areas that are likely to be climate change refugia. And so these areas, we're testing out these methods, working slowly and trying to make, we know that as we change our techniques, we're going to be making mistakes, and we want to make them early and make them small is our goal. So we're taking an experimental approach to our management actions at the moment. And we're really trying to tell this story. And so some of you may have seen the article in the New York Times. On the left, that's a picture of Cadillac Mountain and some of our experimental plots there, surrounded by sandbags, where we're trying to restore native vegetation up there. And so we're working with the national press as well as trying to get this word out locally and doing talks like this to try to make our local communities aware and bring them into the conversations that we're having. Because it really needs to be a community conversation. And so we're doing the science and having the informed conversations so that we can make informed decisions to keep our ecosystems healthy for future generations. And because the science can tell us what the consequences of our decisions might be, but we really need to have these conversations because there's a lot of value judgments. And that there are these similar challenges. This story is playing out all around the world. So this map, the dark green areas are terrestrial protected areas. The dark blue areas are marine protected areas. Every single one of these places was protected with the idea to keep things as they were in the past. Every single one of these places is changing. The managers for all of these areas were trained in how to keep things protected as they were in the past. And we're all having to learn together on the job how to manage change. And so this is a global challenge. We're experiencing it here in Acadia, but really we're part of a global community trying to learn how to manage in this new world. And I want to just kind of end by saying that you can help. There are a variety of ways you can help. One of them is by participating in citizen science efforts here across the National Park Service. We really all national parks are using these 3 apps, iNaturalist, which is for basic biodiversity observations, eBird, which is for birders, you would know that, and then Nature's Notebook is for monitoring phenology, like when plants flower or when birds migrate and when butterflies migrate as well, and things like that. So you can definitely participate in this wherever you are or when you come to Acadia as well. And so I encourage you to continue the tradition. You know, Acadia was started by citizen science, by folks recognizing the beauty of the place, and encourage you to, you know, I know you guys all are, but I encourage you to continue this kind of work going on. And with that, I will wrap up and be glad to take any questions that anybody has. Oh, yeah, I think you're on mute, Gail.
There. Sorry, I was on mute. Thank you very much for a wonderfully informative and comprehensive introduction to this very complex challenge. It's a disheartening story, but the seriousness and the expertise with which you are tackling it does give us some hope. So many thanks to you and your colleagues for the work that you're doing. We have several questions lined up, and I'm going to ask you to be as efficient as you can in answering them so that we can get to all of them. The first one is from Linda Gillies, and she says, could the large population of foraging deer in Acadia be blamed for the disappearance of some plants?
Yeah. So we thought about that and do monitor for herbivory in the park. It turns out that most of the deer population on Mount Desert Island is outside the park. So our coyotes inside the park actually do a remarkably good job of controlling the deer population. And we don't see any signs of herbivory in our long-term forests, in our many dozens of long-term forest monitoring plots inside the park. It turns out that most of the deer are on the edges, kind of around the towns where they get hit by cars, but also where the coyotes don't go chasing after them.
All right, I'm going to use my moderator's prerogative and throw in a question myself. Closer to Islesboro is the Island Institute. Have you worked with them? And if people here on Islesboro were motivated to get involved in some way, would that be a good and natural conduit or channel for doing so?
You know, I've worked with the Island Institute in the past, mostly on education programs and citizen science things. But we haven't worked with them recently, but it would be, I'm sure that the Island Institute is doing relevant things, and they're great organization. And so, yes, I'm confident that there are things, and it would be great to work together again.
Okay.
Yeah, I'd be interested.
Good. Now, from Janice Petzel comes the question, any chance that Acadia will allow planting of the genetically modified chestnut that resists the chestnut blight? Were chestnuts ever common in Acadia?
No, that's a good question. So I don't know the degree to which chestnuts were common in Acadia. I will have to look at that. I'm embarrassed to say that I don't know that. And I don't know about the genetically modified chestnut. My guess is that decision will be made at the whole Park Service level about how the agency thinks about using genetically modified species in restoration efforts. And that may be a federal government-wide decision on that. So it'll be interesting. It's a good question, for sure.
Right. Now we've got a question from a retired professor of philosophy. So get ready for a challenging one. She says, and this is Sue Stafford, I'm sure you've considered this, but why aren't your activities just an example of human hubris? What makes us or you think that you know enough to do all of this management successfully? What even counts as success given the increasing pace of change?
Yeah, it's a very good question. We think about it a lot. Actually, a thing that our superintendent brings up a lot is kind of like, think about 50 years from now or 100 years from now, what are we going to look back at and be like, what were they thinking when we did that? But the situation we're in is one where we know we're going to make mistakes, but whether we take action or don't take action, like there's a possibility of screw up kind of every which way. Like there's no way that that we're not having to, like, inaction is a decision as well. And so what we're trying to do is do the science to kind of help us understand what the consequences, at least to the degree we can, what the consequences of our decisions are, and also take the actions in a way that we can monitor and hopefully be in a position to alter things where we recognize that we've made mistakes, so that we can recognize that we've made mistakes as early as possible. But kind of in the end, you know, things, we only have limited amount of control. We can't even stop all the changes we'd like to stop. And so yeah, I mean, we're trying to make the best decisions we can in an unfortunate situation, for sure. And we definitely recognize that that we don't know as much as we would want, and we're having to kind of make these decisions in unfortunate circumstances.
Well, all I can say is it sounds as if you have a good measure of humility, which is a wonderful quality to have, a certain amount of self-questioning and self-awareness, that you could be headed sometimes down an incorrect path, but you can recognize that and correct and take a different direction that you might find has more benefit and justification. So
Yeah.
humility is a good attribute to have in this struggle. I must say that I found your data extremely persuasive, and the fact that it relates to one environment, the Acadia National Park, makes it easier to grasp, and I think easier to communicate to others who might be climate skeptics, or even worse, climate deniers or climate change deniers. So I think that those data will be very useful. I don't know whether we can easily access them if we wanted to try to call up or retrieve these slides or some of these data you've presented. Are they easily found at the Acadia website?
They are found on a website. So the National Park Service puts its data out in a website with an obscure name. So it's IRMA, which is irma.nps.gov. And there you can find data sets and reports and peer-reviewed literature.
I think you've frozen. Michael?
And whatnot.
Okay, would you
Am I back?
just quickly repeat that website or web link address?
Yeah. It's IRMA, IR.
All right, for some reason, Abe has frozen, and I don't know whether he can.
MA.
Oh, there, I see it. Good, excellent. Okay, very quickly, I have a question from Virginia Reedy. Rather than holding on to the past, is monitoring the change perhaps more valuable than resisting it when it is planet-wide, one world?
Yeah, I think it's I think it comes down to value judgments. I mean, that's a valid question. I think it's a matter of I think a lot of it comes down to what we consider healthy. What do we want our national parks to be, or what do we want our other areas of the world to be, and what kinds of changes are we willing to allow to happen, and where do we think the direction, like where do we think that nudging it in one way could end up with a much better outcome for us, like our management of invasive plants, trying to avoid letting Acadia turn into kind of a shrubland, and instead keep it as a healthy forest. And so those are conversations that we should be having. That's exactly the kind of conversation we should be having.
Excellent.
Yeah.
Abe, I'm afraid we're going to have to cut it there because
No problem.
I have just a couple sentences about next week's program. But I'm so glad that we have you as a resource and working on this science. This has been immensely informative. Your attitude and approach, I think, do you such justice and are extremely commendable. So thank you for taking the time to join us this afternoon. And I'm sure many of us will be following up in our own ways to make use of the information you've shared. So many thanks.
Yeah, thank you very much for inviting me.
All right. And if you'll just hold on for a moment, I'll say to our audience that for our next program on July 18th, we will present Dr. David Van Essen, one of the world's leading experts on the science of brain mapping. His talk is entitled Your Brain, My Brain, and a Chimpanzee's Brain. What's the difference and why should we care? Please join us and have a wonderful rest of your evening. Thank you and good night.